Hello everyone and welcome back to Clear Creek Solutions hydrology education videos. And in today's video, we're going to discuss a problem that is the stream water erosion problem and how pollution can occur in our water bodies and in our streams in more than just one way. Many think pollution can occur in one way, basically by throwing a can of trash into a stream, but there's actually a much bigger problem at play here. One of them involves sedimentation deposit in our streams, causing issues to the water quality and for future environments. So that's what we're going to go over here in this video. So there are many different ways our streams can become polluted. Many believe simply trash in a stream is the most damaging form of pollution. However, what I'm going to discuss here is there's actually many ways our streams can become polluted and how they can build up over time and cause damage to that water supply and that water body. So pollution can be caused by various forms of debris, and these are the ones that are most commonly understood, such as trash, various forms of waste, plastics, and metals. All these can be deposited in streams, and all these things are bad. Especially when pollution can be defined as anything that is introduced directly or indirectly alter the nature of the water body in a negative way. So anything that comes in contact with the water body and causes a negative impact can be defined as pollution. So it's not going to be limited to just those things that we discussed on the previous slide. So there's an additional form of stream erosion that can be easily prevented. Runoff caused by impervious surfaces such as roads, sidewalks, will increase erosion and sediment in streams. So what is stream erosion protection? So there's sedimentation. When stormwater runoff is generated from a project site, that water must eventually flow somewhere. This water will carry sedimentation that has eroded from the project site, and this sedimentation will eventually reach a stream or a water body. Now, what are the problems with this? Additional sedimentation can have many damaging impacts on drinking water, wildlife, stormwater systems, and plant life. Some sedimentation is inevitable, but too much erosion is definitely a problem. So obviously in a natural environment, when stormwater rains on a site or an area, there's going to be natural erosion and sedimentation that is eventually deposited in streams. And that's fine. That's been occurring for a very, very long time. But it's when we add impervious surfaces to a natural environment that increases the amount of runoff, increases this range of erosive flows, and then this additional sedimentation begins being deposited in streams that it begins to have this negative impact. So what are some of the typical mitigation measures that people put in place? Some of these temporary ones, something like a storm drain filter, which is the implemented filtration device, which is intended to remove large sedimentation. There's a silt fence, a fence that prevents sedimentation from spreading in large areas. There's turbidity curtains, and these curtains can be utilized in the water body, but really only employed as a last resort. And there's something like sedimentation barriers, which are safe drinking water wells installed barriers that allow water to pass through while filtering out sedimentation and other large objects. It's estimated that $16 billion is the cost of damage caused by stream pollution, and this is according to the EPA. So this is a big problem that is not also damaging to the natural environment, our water supply, wildlife, but it's also very costly. So for stream protection, we can do it through modeling. Stormwater detention is modeled based on preventing erosive flows from being released from the project site. And how is this done? Well, there's a couple of different forms. One form is single event hydrology methods, which can only primarily account for the runoff volume in a design and not the release rate to the stream. So single event modeling is limited and unfortunately is still widely used for facility design and modeling across the world and across the country. And it's a very limited methodology when we're tackling these things. So how do we do it in Western Washington? Well, the erosive flow range that was determined to be damaging to local water bodies in this region is half the 2-year flow to the 50-year flow rate. And for other jurisdictions that utilize continuous simulation, we've determined other various flow ranges. So for Western Washington, it's half the 2-year to the 50-year flow rate. So what is the process here? We enter the project area, we utilize our 50+ years of rainfall data, which is then used to calculate a runoff distribution. A detention pond or other mitigation method is used to mitigate that erosive flow range, and the erosion will be prevented due to the site development now because of that mitigation measure. So here's an example of a flow duration curve that we find in a program such as wwhm 2012. The blue line represents the pre-developed curve, which shows the flow rate on the left and the percent time that flow is being exceeded. And on the right, on the red, it shows the mitigated flow rate. We want that mitigated line below the pre-developed line so we don't have any additional flows exceeding what the natural environment was used to. So what is a flow duration analysis? Facilities are designed based on flow duration analysis, allowing for a proper facility and outlet release rate back into the natural environment. So we plot the flow duration curve in that pre-developed scenario, that was the blue line. Then we plot the flow duration curve in the developed scenario, that was the red line. Then we design the facility with the proper release rate for that half the 2-year to 50-year the flow range, and then execute project design to properly mitigate project developments and the construction. So by resolving this erosion problem using something like continuous simulation, we can protect our streams and in kind improve the quality of drinking water, wildlife, and communities. So we should learn to utilize this power of continuous simulation to create better designs, better mitigation measures, and protect our natural environment and water supplies. So by utilizing this form of hydrology and creating our facilities better, we can prevent these erosive flows from reaching our streams in the first place and improve the quality of the water bodies in our local community. So to learn more about continuous simulation hydrology, you can view other Clear Creek Solution videos where we go over continuous simulation very much in depth, or you can check out some of our software that involve this methodology. Here's some of the works referenced. I thank you so much for watching this video, and anyways, we will see you guys next time.